In this video, I'm going to explain how to solve using Gaussian elimination or Gauss-Jordan method. So the equation which is given to us is x plus y minus z equal to 9, y plus 3z equal to 3, and minus x minus 2z equal to 2. So we write this equation into what is known as an augmented matrix. So if you see, you have 1 into x plus 1 into y minus 1 into z equal to 9. So we write those constants here. You have 1 into x, so 1 comes here, 1 into y, so 1 comes here, and plus minus 1 into z, therefore minus 1 comes here. And then I've drawn this line, and the elements on the right hand side will show you these constants. So you have 9 here. Similarly, you have 1 into y, therefore there's 0 for the x position, and you have 1 into y, and then 3 into z, and then you have 3, which is the constant. Likewise, we have written the contents of the third equation as well. Now the task is to write it in a row echelon form. So what is this row echelon form? You write the matrix, this matrix, augmented matrix, in the triangular form, which basically means that the leading coefficient in each row must be 1, and also you must have ones along the main diagonal. So if you look at this matrix which we have created, this will be the diagonal which we want, right? So the other aspect that we need to remember to convert the matrix into a row echelon form is the entries below the main diagonal must be 0. Okay, so now we'll start with the echelon form, or trying to get the matrix into an echelon form. So I have rewritten the matrix here. You have 1 1 minus 1 9, 0 1 3 3, and then minus 1 0 minus 2 2. For your reference, I have also put the structure around the main diagonal. So you have 1 1 and minus 2. So let's try this conversion first. So I'm going to write row 3 as row 1 plus row 3, because I want this first component to be 0. Because if you look at the first statement which we have written, the second statement, which is entries below the main diagonal must be 0. So all the entries below this main diagonal must be 0. So you have 0 here and 0 here, but you do not have a 0 here. So by doing this r3 equal to r1 plus r3, you can see that I'll get this first element as a 0. So when you do r3 equal to r1 plus r3, you get these elements here. Again, I have marked the main diagonal. Then in the next process, I go with r3 equal to r3 minus 1 into r2. And then once you do that, the matrix turns out to be like this. Again, I have marked the main diagonal, right? So then in the next matrix, I have marked x, y, z, the components here, and the constants. And you can see here in the previous matrix, you have 1 1, but you have a minus 6 here, and it's written here that you should have ones along the main diagonal, right? So therefore the next task is to convert this minus 6 into a 1. Therefore in this final matrix, I have taken r3 equal to minus 1 by 6 r3. So once you do that, then you get all ones, and you can see that all the elements below these ones are 0, and then the other elements can be whatever. So once you have the matrix in this form, you can say that you have reduced it to a row echelon form. Now you write this augmented matrix in the form of equation. So you have 1 into x plus 1 into y minus 1 into z equal to 9, 0 into x plus 1 into y plus 3 into z equal to 3, 0 into x plus 0 into y plus 1 into z equal to minus 4 by 3. From here you will get the values of z, y and x, which is exactly what we wanted to find. Now three things which we must remember. Only row operations are allowed. We have not done any operation on columns. Therefore, to convert a matrix into a row echelon form, for Gauss-Jordan method or Gauss elimination method, only row operations will be allowed. The second thing that we need to remember is reduce the matrix to an upper triangular matrix form with ones in the main diagonal. An upper triangular matrix is a matrix where the diagonals will be ones, and all the elements below the diagonal will be zeros. And then the third thing will be, by doing this row echelon form, you can also find the rank of the matrix. The rank of the matrix is nothing but the number of 0 rows. Okay, I'll also be posting a video on rank of matrix later on, so we'll see how to find the rank of the matrix. So once you find the matrix in this form here, the main diagonal being 0 and all the elements below this main diagonals as 0, then you can say that you have reduced the matrix into a row echelon form.